All right, and welcome to the last week of spring semester 2020. I don't think many of us imagined this is how the semester would be ending, and I never really got to say goodbye to you guys, but I hope you're doing well. I know this is a big adjustment for a lot of people, and if you were planning on working this summer, I wish you best of luck finding a job. I know a lot of us depend on our summer employment, so if you need any help or recommendations, let me know and I'll be more than happy to help you out. Other than that, let's stay focused on this last week of review. I'll have a video for you today that I'm posting, and then I will have Thursday's materials once Sherry gets those posted. My timeliness kind of depends on when she's posting stuff right now because I'm pretty much almost done with most of my classwork, and I hope most of you are in the same. I'm going to be posting a practice final exam, and it's going to be about close to the length question number wise that you could expect on a final. It's going to be more than a midterm, obviously. This is a cumulative final. But the set of problems that I'm going over in this video are over the practice problems that I'm also going to be posting with this video. So do the practice problems first so that the video makes a little bit more sense. You are less than a week out from your exam. Next Monday, same format to midterm 3. So if you had questions over midterm 3, make sure we get those addressed so that we know what's to expect. But without further ado, let's talk about 2.8. And for some of these today, I'm mostly going to only have one practice problem because it's all pretty much repetitive. Except for the last one, I do have 2 different ones. But for the composition of functions, I really wanted to go over this chart because not only could you be asked to compose 2 functions, which you could be given a chart or a graph, and I think most of us have seen compositions of functions before, so that doesn't throw us off, but sometimes when we see a chart or graph, it's kind of a different format than we've seen before. And I chose to give you the chart because that seems to be a little bit more common on exams. So first thing we need to pay attention to is our sign differences. This means a composition. That just means a multiplication. So we need to use this value here. We want to go up to that value on the chart. So, and we are just multiplying them together. So we're going to do f of -1 times g of -1, which is equal to 8 times 4. So we see the answer for part A is 32. Pretty straightforward. But then when we get to this really means f of g of -3. So first we need to figure out what g of -3 is. And then we are left with f of 5. But when we go up here to this top row, x is never equal to 5. And this value in here is what our x would be. So don't be caught off guard by this. That just means you have an undefined answer for this one. And that's perfectly okay. So then here we have our typical division. And we're going to divide g of 7 divided by f of 7. So we need to go up to our 7. And we're going to divide g, which is on the bottom, first. So we'll have -2 divided by -6 divided by -2, which is equal to 3. And then we're going to do our last composition here, which is the same as saying g of f of 2. So f of 2 is equal to g of 7. And g of 7 is equal to -6. So this is pretty straightforward. You just kind of have to follow along to try to make sure all the values do line up. So if you have any questions on this, if you go back to original notes, There's more examples. Now, moving on to 3.1. You're getting into some different types of graphing that you did not really see before. But let's look at this one. And this isn't the same as that transformations of function stuff that we did. This is a little bit different because it's asking you for different things. And we aren't moving the graph, we're just solving the graph. Define the graph, I should say. So to determine if it's going up or down, you need to look at the sign of this leading coefficient. Positive equals up, negative equals down. So obviously in this situation, there's not a negative sign, so we can assume it's going up. And then for the vertex, we can use the vertex form. Negative b over 2a. Which, this is our A, this is our B, this is our C. But assume there's a 1 out front. So we have negative of negative 4 all over 2 times 1, which equals 4 over 2. So our vertex is at 2 comma something. And so we need to plug in our 2 up into our original function to get our y-coordinate. So if I do 2 squared minus 4 times 2 plus 3, I get 4 minus 8 plus 3, which equals negative 1. So I see that my vertex, is at 2 comma negative 1. Make sure it's always a coordinate pair. And I put this note up here just to touch on quick. This process is pretty much the same every time. You're looking for the same things every single time. Up and down, the vertex, which is always negative b over 2a, and then our x-intercepts and our y-intercepts. So to find our x-intercepts, we want to plug in y equals to 0. And to find our y-intercepts, we need to plug in x is equal to 0. So when we set y equals to 0, here we say 0 equals x squared minus 4x plus 3. How can we factor that? Well, we could do right? So we would have x-intercepts at x equals 1 comma 0 and 3 comma 0. These are also always in pairs. I'm going to highlight those and my vertex so I don't lose that. Okay. And now I'm going to solve for my y-intercept where I plug in x is equal to 0. So I get 0 squared minus 4 times 0 plus 3, which is equal to 3. So 0 comma 3 is my y-intercept. So now I'm going to move down here and plot this on my graph here. This is not expected to be perfect. You really just want to plug in your 4 points and use this that we put up here for to see if it's an upwards or downwards facing parabola. And why is it a parabola? Because it's x squared. And see what it looks like. And label everything. So we have 2 comma negative 1. We have 1 comma 0. And we have 3 comma 0. And we have our x-intercept at 0 comma 3. So we know, because it's an upward facing parabola, it's going to look something like this. Okay. So you're going to do the same things for number 2 and 3 for 3.1 that I'm sending you. So now we're going to move on to the introduction of polynomial functions, which it was kind of newish right before we went on spring break, and then we came back and we never really came back to the classroom. So this section was right before spring break, and some of you might not remember the most of it, so I would recommend looking back on it because it's a really great exam question. And same thing for 3.1 as 3.2.